Live from Twitch TV, and we are back. So, yesterday we kind of had to fall off in a hurry because I had to run out, but let's get back into it. There's our socket stream handler. So what I want to do is actually want to write tests for the socket store, and let's see here, where is the socket store test? There it is. I'm going to actually move this over here. Not that makes a huge difference, but so what I wanted to know is if the name is carried over. Never did quite have a chance to look that up, but I think it's fine without it. I think we're okay just to do this. I think it does the name by default, but we'll find out. I'm not too concerned about it. So we start our link, we exit our PID, so should be able to store lookup. So we passed this player in. So what I'm thinking through is thinking through this this morning. So let's look at the socket acceptor. So what we're going to do is we're going to receive a port, and what we're going to do is we're going to create a player. Probably look them up later from that, and then store that into our socket store. And then we'll have a separate process that goes through, pulls all those sockets or all those players and operates them with their units and whatnot. So we're actually just going to do the updates and then find out what we have to do with those. So there's going to be kind of a bit of work here, but I think we're trying to do as little as possible. We might not even need this. We might even just store it straight ahead in the other module. So let's just finish this off real quick. Should store PID associated with player, and that's what we're going to do. So, and then we'll have the player have their port. So we're just going to do socket store. Where's our implementation? We're going to say store PID, and we're going to give it a player. So it's going to be, that should be fine because it doesn't really matter because we don't actually check anything in here. So this should be okay for now. Maybe we'll need to later, but we should be okay. And then one more thing is we'll do a def call get player PID state do, and we'll just do reply map get state, and actually let's keep that empty. So I think it'll likely just give us a bad match, but that's okay. So we're going to say assert socket store get player. What we'll need to do is we need to store this into, we'll need to bind to this to a different variable as this. And we're going to keep this very light for now because don't know much more we're going to do with this right away. So should get player is going to do PID, and that should equal our player. So I'm going to test that. That should give us a couple errors. Unexpected 2. That's socket store number line 4. Let's look back here. X actor. So here, start link. Oh, just missing the colon. Oops. Still coughing today. And undefined function PID. That's on the test on line 17. Oh, we don't have a PID. So what can we do here? We could probably just do PID equals OK PID equals agent start link function nil, and that should give us a PID. I hate when this does this. Too smart by half. Okay, so we have a lot of interesting errors here. Oh, I think it's because we have all this in place. So let's get rid of most of this, in fact all of it. And next test. Okay, so there's our fail right there. So it doesn't have a store function too. So take a look here. It should be what was our error here? Undefined function, game server, IO socket store with arity of 2. So not sure why it's doing that. I'm just going to make sure that's written, because it should be line 18. I'm curious if, because I think this actually ends up being like this. I'm going to drop those in here just to see if that gives us any insight to what's going on. So it didn't throw an error. So I'm going to drop player. I'm just going to follow how this is looking just to make sure we've got the API correct. We've got def call get, that's going to get all the state. So we're just going to do def call store that, and we're going to, just to see if this is an issue, we're just trying to get past this first problem here, saying that doesn't exist. Game server IO socket store does not have one argument. Player test. Here we go. Bad call. So it looks like player, and we're just going to do reply. See how this reply works. Alright, it was like the first thing, just reply OK. So that's what we just need that. Next test. Let's see if that gives us any sort of, no. So it's saying it's undefined function, so it seems weird. Let's see here. Let's get the other def calls happening, see if there's any. Okay, def call P. So this is similar to what we have. It's def call P, which is the same thing we do. So except for they're doing a private function, so that's okay. And we have our state. In fact, we can call this player map. And what are we missing here? Reply OK, store, handle info. It should be fine. Diff call. Saying it doesn't exist. What's interesting is I have this, I've done this in different projects. So let's take a look at that. GitHub, oops, that's fine for now. I built this in Pandemic. See if this gives us any insight, because I'm pretty sure draw card, so still nothing as far as passing arguments. So let's try that. We're just going to pass nothing and see if it, yes, it's not, still not giving us what we need. So let's take a look at what I did here. So game server, that's a good one. Ah, okay. So looks like here this is our setting our name. So let's just look around our card server. Yeah, see, it looks like that's what's doing our name. So let's try that. So it's xactor export. We'll call this socket store. That's the name. Okay. We're getting a different result, which is good. And socket store line 6, handle call get player. So we're just gonna PID player. I think this is, we've actually broken down the problem. And this is gonna be PID player. Okay, there we go. So get player, I'm going to say reply okay as well. Let's see if that, okay, there we go. So that's the what we need. So now we can do we'll call this player map. Player map. We can do player map, and we can do map get. Let's actually add the pipe operator. Get PID, and then we'll pipe that into our reply. Over here, we're going to do our player map, and we're going to do map put new PID player and we're going to just reply with okay. Actually, what we could do is we can do set and reply okay. test. There we go, passed. All right, so it was actually harder to get it to fail just because I didn't get all of this stuff. So I'm wondering, kind of like the idea of having multiple socket stores with PIDs. So I'm going to try something real quick. I'm actually going to comment this out, and I'm going to add the server, which is this module, and see if just going to play a little bit. So we have the PID. What we're going to do is we're going to close this out. The tests, I think I had, here we go. Trying to make sure, I think it's an OK and a, yeah. So we're going to say OK, and then we're going to have server PID like that, and then that'll pass the map down to this. And it's going to be the server PID. Let's see here. PID, serve. And then, because it'll pattern match this atom with this atom, so it'll automatically assign it. So now we would pass this and this. Let's test. And that does not pass. Okay, so it does have, so I think it'll resolve this automatically, which is actually pretty cool. So let's do mix test, and that's awesome. Okay, that is perfect. That's exactly what I wanted. So now we can have multiple socket stores for the player. So you might be thinking like, well, why do we need multiple storage for our sockets? So the idea here is with Elixir and Erlang is we could potentially have multiple servers, and so we can register these servers globally across all the servers, and when we say, okay, socket store with this port, we can just assign it to the right server, and then when we know where the socket is now, and so when we say update the player, it'll actually write to the correct socket, because we can't actually pass the sockets between servers. Hope that wasn't too loaded of a statement, but that's why I'm doing it. So since we can't pass sockets to servers, we can pass PIDs to servers and have them communicate. We can't actually pass the sockets around the ports specifically. So we need to stick with that. And if you're curious why I know about the sockets and the ports thing, because I tried it. I tried passing ports around to see if I could rewrite to the socket. Didn't happen. And then if anyone's curious to see me try it, and I'll be happy to do it and show you guys how I tested it and how I was able to come to the conclusion that it doesn't work that way. One more thing. We need to do a def call remove player PID player map to end, and we're going to do reply with OK. And what we're going to do is test should remove player by PID, and we're going to pass our serve v to end, and we just need this inc, and we're going to store it, and then we're going to remove player. So socket store remove player serve PID, and then this one is going to be, this one's going to be nil. Okay, fails. Now we're going to do player map I'm gonna look at the docs real quick. Map. Can't remember if it's remove or delete. It looks like survey says drop. Given keys, so we're gonna drop delete. Delete. PID. And we're just going to set this to reply. And I'm actually going to write these here. So mix test. Okay. Get player server PID nil. Left hand side was we need to do set and reply. Okay, that'll do it. Test. There we go. So now we've got store and delete. So that's good. So now, just in the interim, I'm going to create the make directory, the game server. We'll call this models, I guess. Why not? Live game server models player .ex def module player do and def struct. We'll just do ID nil, name, why not, and then we'll do port nil so that we can store the port for the player. We may not need name right now, but we have it, so might as well go with it. So we're storing the PIDs, and now I'm looking at the socket stream handler. So let me think about this for a second. I think we're going to go to the test game server socket server test. And instead of passing this on to the socket acceptor, I could just store it right there. But I think I'm going to keep the socket acceptor for now. Test that separately. Just so that just thinking. In fact, yeah, we can handle the socket acceptor and look up the player. I'm going to stick with what I've got. So test game server socket acceptor test EXS read in test game server socket server test. Don't need that. So this is going to receive a. Don't need this one open anymore. Yeah, lib game server socket server. Client connected. So this is actually going to be the client port. So the socket acceptor will create a PID with a player associated with it. I'm trying to think if the PID is necessary. Let's just go with it. You can always pull it back. So what we're going to do is we're working with the socket server test. We don't need that anymore. Okay. Socket acceptor. Talk test game server. Okay, so we don't need that. We don't need most of this, so I'm just going to take it all out. And one thing we need to do, just thinking through this, lib game server socket acceptor is we need to start this as an app. So a couple things we can do here. So what I'm thinking through is we're trying to use our socket store. Now our socket store hasn't been started. Maybe it has. That's probably what to decide on. Do we start the? It seems like a big job for the client connected to start up the socket, but at the same time we don't have the PID for it. So what we could do is, I'm just going to keep that inspect in here, is we'll write a test for this. So what we're going to do, I'm going to leave that, and I'm going to leave this. So VI, we have the test ready. So test should get, I'm going to need a setup as well. Should store, should create process and store player. In, what do we call this? Socket store. Actually, call it player store. And this is going to be a, do this for now. Okay. Thinking through this, yeah, socket store is not the right name. It is actually a player storage facility because we're actually storing the socket. So just move that. Lib game server IO socket store to lib game server. We're going to call this, darn, okay, make directory lib game server. We're going to call this state. We could put it in the models. I don't want to. I want to keep those real shy. So we'll call it state. So we're going to game server state and player store ex. We are lib game server state player store. Call this player store. Move test or make directory test game server state. Move test game server IO to test game server state player store test EXS test game server state player store test. state player store, state player store. Sorry, I'm about to clear my throat. Player store, player store. Let's see here. Socket store, player store. There we go. One more thing that I think I missed was here, which is state. And next text. See how close we got. We got it. Okay, good. Okay. So now, thinking. Trying to decide if I want to store the PID, because this is only on accept. Now, once we get to the handling of the socket, we could iterate through them. So if we store it just as a player, we could store it as a list. We can iterate the list on update. We just iterate that list so it'll be faster. And then each of those could be a process. Alright, either way, I think I'm just going to keep rolling with what I've got. So now, I'm going to say should create process and store player and player store. So we're going to say socket acceptor. And what's the API here? Lib, game server, socket acceptor, port. Darn it. Is a port. Client connected. And we're going to, this will be our client connected. And we'll need our store PID, store PID. Therefore, we'll need a setup. We'll call this the game server. I'm just going to alias it. State player store. I'm going to do OK. PID equals player store start link. And then where was test game server state on exit is our callback. Exit, is it just a function? Yes. Exit function. That's gonna do its thing that it usually does that I can't stand. And we're going to do process to exit. I believe it's exit. Exit PID and status by normal. That cleans up. And then do OK. Store PID. Store PID. PID. Okay. Client connected will be the client. And what we'll need to do is talk to our player store. So this will be our player store get player. Is that what we call it? Store get player. Okay, get player store PID and our we don't actually know the PID, and so that's where the problem lies. We don't actually know it. So thinking and if we change this to PID here, That's why I'm thinking that we should. So there's a couple schools of thought here. So if we do the player store and we match it by PID, we can be able to look it up by PID again later. So that's an interesting thing is if we make a PID store just for the PIDs, when we iterate that, we can get the player, so it becomes a level up above it. And so still thinking through this here. Okay, so trying to think of a good way to do this. I don't like the fact that the player store, we lose our flexibility with our player store if we pass PID, because likely we'll be just iterating all the players on an update. So let's require some thought here. We have GIMP installed? We do. Let's draw this out. So sometimes we just need to visualize what we're doing here. So we're just going to do a new, that should be plenty, and then we need a toolbox. And what's the size? I forget to change how to change the size here. Hardness. Spacing basic. Well, okay. How embarrassing. Okay, so there's that. What's the size? Layers. That's definitely not it. There we go. That should be plenty. There we go. Okay, so we have our connection come in, and it gets accepted. Accepted. So now what we can do, so we have a different, we're going to have a different process that's going to go through and we're gonna, just like we do on our game where we call update, we're gonna need to do the same thing. So what we can do, one school of thought, is that we go through our collection of players, and they all have their ports here, and so we can iterate through there and we can actually check them, but it makes them happen serially, which means one by one, and we don't really need to do that. We could, and maybe we should keep it simple for now. You can always break this down into PIDs later and have each player have their own PID. But right now we're storing it all into the player store anyways. So maybe we don't need to worry about, because then we could just run this big old loop here and pass that on to the game. And then this is our game here that's going to do all of our logic. And so and these are the player, this is technically just the socket. And so any sort of units and things like that, we can spawn processes for them. So maybe having this come in serially is not a bad idea. The problem is that the order of connection gives the player priority, and that's not that fantastic. We could technically random them, but does it really matter? Probably not. As we read the data off the sockets. And having them operate in a serial fashion might be better anyways. The other side is that we can have them all operate in parallel, reading off the socket, and then passing that data to the game. And the game can be sort of a bottleneck as far as PIDs. There's only one PID here. And so all these guys can be running, instead of having one gigantic main loop for iterating through all the players, we have one PID that's updating, which I actually like that idea better. And those will communicate with the game. So let's do that. I like that idea. So what we're doing is each player is a PID, pi. And then, so as soon as a player is created, we start them up into a loop. With the PID. And I do like that idea. So, what we're going to do is we're going to take this PID out. We're going to keep this interface the same. We can do, what we can do is when we do the client connected, we'll return the PID here. Now we can get our player. And now we can do assert player port equals client. And that'll do it. So now it's interesting. Okay, just thinking through the problem. Mix test, so that should fail. Okay, match on right hand side, client connected, and 20. Oh yeah, so that would, this doesn't match, that's fine. That's our technical fail test. And what we can do, we can just do this. Okay, nil. That'll at least make the match happen. There we go, see? And now, what we can do is we can say when we get our connection, we'll create our player. This will be player ID, we'll just call this 1 for now, name, foo, and we'll come back and change this stuff later. And then our port is going to be port. Okay, and then we're going to go to our, we need to create a PID. So this is going to be PID process dot spawn, and for now we're just going to call this, we're going to stick this in the player. That's probably going to change. We just need a place to store it for now, models. I'm going to call this dev update. And we're going to give it the player. Okay. So now we can, let's see here. I think we could actually just, yeah, this will work out great. Okay, yeah, I'm really excited about this now. Spawn, player, update, and the argument's going to be the player, so we have access to the player. And now we're going to do player, so alias, game server, state, player store. Okay, oh, I'm getting excited now. So now, one thing we don't have is we need to do process where is, and what we're going to need to do is we need to come up with a process name for now. So we're going to change this. It's going to come out of some sort of config file, but right now we're just going to store this as a variable here. We're going to say process or player store. We'll call this 1 for now. So player store. So that'll give us our process for our player store PID. And now we do player store store, I think that's what we called it. Store our player store PID, and we'll need our PID and our player. Boom. And now we have our PID to return. So let's test, and we have a problem with spawn 3. So let's take a look at our process. Spawn, and ooh, I think we need to actually spawn link. Spawn and register. Oh, we need to register too. And we also need port if there's not such a link already. So there's a couple things we need to sort of set up here. And maybe so we also need to register. Oh no, we don't need to do that yet. what we need to do is we need to actually register this PID. So we're going to do process dot register. Make sure I got the register, the PID, and then the name. So this one's going to be 1. There we go. And so here spawns a given module. So module, which we have, what's it here? So spawn module, our atom for our function, and our list for the arguments, and then we have spawn options, which is link, monitor, priority, full sweep, I think. I think we actually want to do link. Like that. Argument error. And it is spawn object linked. Link. Let's see here. Spawn. Where are we at here? Did I lose it? Register. Here's the spawn func options. Here we are. Okay, spawns a module given function path arguments given options. The result depends on the given options. The particular monitor is given as an option. Return a tuple containing the PID and the monitoring reference. Otherwise, just spawn process ID. Also expects extra options for the available list. Check this. Link. So there's a spawn link. So where is spawn link? Might be in the kernel. Let's check the kernel. There we are. That's the one I want. So we're going to do spawn link. And see if that does what we want. There we go. Client connected. So I'm going to keep that. I think what we can do is we can import logger. Logger, see here, Elixir logger. And I'll just do debug. There we go. So that's looking pretty good. And we got it all put together nicely. All right, so let's do, the thing I don't like about this is we're not actually putting a, we might have to monitor this, and I think we can do that. I think that'll be okay. One problem we have, no, because they'll update themselves. Okay. Yeah, there's something about this that is a little weird. How we're not having it monitored, and that'll be something we'll get into later. But in the meantime, here, test should remove process. So this is a problem here, because we can't actually kill the process. We have to store the process separate, and that's okay. I'm actually kind of okay with that. So the idea is we can't actually remove the process right now. So should remove, terminate process if disconnected. Okay. Store PID, store PID. Do. And we're going to leave this test ready to go. So I think we can just call fail. And no function fail, say unfinished. Maybe. Nope, there's no fail function. Okay. Next unit. Is there a fail? What is the assertion, maybe? I guess we could just do assert. Catch actually kind of refute. No. So I'll just say, can we do assert with a message? As refute, assert assertion. Assert raise. Flunk. Flunk should raise an error. Okay. So I'll flunk it. Unfinished. So when we run our tests, we'll know that that's unfinished. Okay, so I think here we are missing some commits here. So git commit added unit actions and input, and we'll do git push origin master origin master, the date, git tag 16 06 03, and this is going to be 0904 git gut push origin, this thing, and git status git add lib di.gitignore es store. Why don't we just add this by default? Okay, git add lib, git add test, git status. Make sure everything's good. Okay, git commit added some socket handler stuff and player store. Boom. There we have it. All right. We did some elixir